guys, because in acids and bases, we're often going to be mixing two volumes together. And guys, if you have 20 milliliters of water and you add it to 20 milliliters of water, is that only 20 milliliters of water?
No.
No, how many milliliters of water is that?
40.
40. So what that means is your concentration will be changed, and you'll also have some reactions happening. So in this case, is HBr and HNO3, are these two both considered acids? Yeah, right, because what do they have in front? Okay, that's one of the big hints, is that they'll have the H in front. And are those two on our big list, our strong list? It's on the list of 6, right?
Yes.
So therefore, instead of thinking of these as two different acids, are these technically the same?
Yeah.
Because for all that we've seen, this one will actually be the same thing as H3O plus or H plus, right? Because what does HBr immediately do when it hits water?
Dissipates.
Dissociates, exactly.
Completely.
I
Why
knew
it's
what I
strong.
was saying as to where, and that's.
No, I know. No, that's why I'm like, yeah, good job. So it completely dissociates. So as a result, this isn't really HBr if we want to really go there and think about it. It's really H3O plus, right guys? And then can we say the same thing about HNO3? Did we even, actually just an aside, did we even need to know about acids to know that HNO3 is going to be a strong acid?
No.
Because what does it have right here?
NO3.
Oh, NO3, which always dissolves.
NO3 always dissolves. Very good. So HNO3 we should know intuitively is going to be a strong acid. And remember, a strong acid is defined as anything where the H plus comes off what percentage of the time?
All the time.
Basically all of the time, right? So what this means is we can convert both of these into moles, and then we can just add them together to get the total H3O plus when we add these. And then why do I have to do this denominator step? Why do I have to add the two volumes together? Go ahead, sir. Because the volume is additive, right? And so that gives us our new molarity. Because guys, you have to have a molarity to use the negative log. And that's because what is this H3O plus in right here? And what do brackets mean, guys? Molarity. Yes, Avi?
In a multiple, say this is a multiple choice question, we wouldn't have something that's like 0.17 molarity. It'd be like an obvious.
Everything's going to be relatively obvious, yeah.
Okay.
All right, so then that's how you would get the pH in a problem like this, okay? So in terms of, our steps and all that, a problem like this is really straightforward. Okay. So let's look at the H plus from the auto dissociation of water. It's not going to be important when finding the pH, and there's two reasons for this. First off, 10 to the negative 7, which is what they are as a baseline for the OH and the H2O plus, is a very small number. And Le Chatelier's principle says that when you increase the H plus concentration, it'll shift the equilibrium for this auto dissociation towards H2O, thereby reducing the concentration of H plus from this process. Long story short, guys, auto dissociation of water is important to know about from a theoretical standpoint, that you could just have water sitting there and it'll have some of it go into OH and some of it will become H3O plus. But effectively, when it comes to math, does it matter? No, because water is what pH?
7.
Water is 7, it behaves neutrally. And if you were to add some H plus to it, it'll just shift it right back. Because remember, what does Le Chatelier say, guys? We add H plus, where's it going to go? To the water. So neither one of these gets an advantage just from auto dissociation. Auto means automatically, right? Now, what if I add some acid to here? Is it gonna make the pH go down if I add acid? Yeah, because then it's actually a separate chemistry you're adding to it. This slide is only referring to water hitting its own water, okay? And yeah, if we can have pH, then we can have POH, yes.
Go back, just 3 slides.
To here?
Wait, no, it's all the way forward. The way it said like the 2 ways H plus is not important in finding pH. Thank you.
You guys having a good Friday?
It's okay.
What's happening? Did you guys have a test in the AP class?
No, it just kind of slow.
Statistics test, and I messed something up. I messed up the definition of 2 things, and it was like most of the test, so I got probably like a D on it.
Oh.
And then I have another test in A-push, and then I have solo and ensemble.
Did you guys have a substitute in Ramirez's class on Wednesday?
Every day.
Like Wednesday at 7th period?
The whole week.
They asked me to do that, and I was like, nah.
I see that you saw Bianca yesterday.
Wait, that's not even me.
Yeah, she's really cool. I told her that you two are very different from each other.
See who you are. We should never have him.
Yeah. Alright, I asked her which one of the siblings was the coolest.
Wait, which one did? What did you say?
I can't answer that question.
Wow.
But I asked her which one was like the baddest, like the criminal of
The-
them. And we both agreed that it was Francesca.
Francesca.
She's the rebel. Alright, moving on, guys. If we can have pH, we can have POH. But guys, I want to stress before we look at this, which one is the standard that we use everywhere, including elementary and middle school science?
pH.
pH. So pH is the gold standard. Now, pH obviously is looking at things from the perspective of what? OH or H?
OH.
H, right? Whereas
Oh, I'm so
POH is looking at it from the perspective of the OH, okay? It's just one of those things, we chose pH to be the standard, so that no one gets confused, right? However, mathematically, POH does have some uses, and it is a valid thing. And you guys are going to see there's going to be a lot of practice problems where the only way to find the pH is to first find the POH, because, guys, if you've got a reaction where it's trading around OH minuses, right, there's not really any H pluses per se, right? And in which case we can find a pH, but first we will have to find the POH. Okay, so very simply, guys, negative log of OH minus. Guys, if they give you a concentration of anything from Li, NaK, Rb, CSFR, CaSRBa, and OH, can you just take the negative log of it to get the POH? Yes, because those that I listed are all considered what bases? Strong bases. So, this example, find the POH of a 1.5 molarity KOH solution. This is a strong base, so we assume complete dissociation. Okay, so guys, all we gotta do is take the negative log of
1.5.
1.5, and that gives us a POH of negative 0.18. And that's it. Yes, sir.
What does the scale look like for POH? Like I would assume
It's
that
the
it.
same,
Yes.
1 to 14.
So, but that's a negative
It's a
number.
negative 0.18
Yeah, I know.
up there.
No. My point was that in the pH scale, the lower number, the lower the number that is,
So yeah, in this scale, the lower number would be OH favored.
so the more basic it would
So
get.
it's like opposite, yeah.
Yeah.
All right. And it would make sense too, looking at the math, because we know KOH is a strong base, and look, it's throwing us a negative 0.18. So yeah, guys, when you've seen pH previously in your lives, you may have only ever thought it was 1 to 14. It is in fact very possible to be below 1 or above 14, and that's where things get really scary. Which is why you didn't see it previously. Alright guys, any questions about this before I move on to acid base 2? Alright, let's go. Alright guys, acids and bases 2.
Just a little too eager to put acids and bases.
So guys, remember when we had KP, KC, KSP?
Yay!
It has returned!
Is this unit harder than equilibrium?
Well, by default, it has to be because equilibrium is the backbone of this one. So everything we did in equilibrium, we're gonna do
But then we
here.
go to kinetics.
Yeah, kinetics is nice and easy.
Because my self-esteem is slow.
No, don't worry.
Every test that.
Don't worry. Kinetics is nice and easy.
Is it math? Is it?
Oh, it is math, yes.
Will it like boost our grades?
Kinetics always boosts every year.
And that's fourth quarter, right? So it's like.
Yeah, and kinetics will be the basis of your fourth quarter grade.
Have you gotten any
So-
A+ tests in the kinetics?
Huh?
Have you gotten any A+ tests for kinetics?
I've gotten 100% on it before, yeah. It's the
Dang.
only one I've gotten hundreds on.
Dang.
Wait, what? Can you not do the third quarter?
What?
Can
We're
we stop right here?
Can we
and go to kinetics?
can we do kinetics in third quarter? That'd be fun.
No.
No, we just gotta get this over with, guys. We gotta
I
get
need
this
it
over
to be
with.
fourth quarter just in case I
Alright,
screw up there.
so guys, we're gonna look at Ka and Kb. So basically, acid basis 2 is where, because last time we saw, oh hey, strong acids and bases, yeah, easy. And today we bring in
Weaklings.
weak acids and bases. Now, I want to note, I just want to stress, I know I said this a lot last class, but I really want to drive the point home. When we say strong and weak, we're not making any comment as to whether or not this is dangerous or could seriously burn or injure you. If they're weak, acid and base, they could still do a lot of damage to you. Like, in fact, a lot of the most dangerous ones to us are actually weak. The weak and strong definition, it's kind of an unfortunate classification because they are, in effective personal terms, very strong still, many of them. But when it comes to chemistry, they don't go 100%, so they're not considered strong. Yes?
So then what constitutes an acid or a base as weak or strong?
You mean that's like dangerous?
No, like definition-wise, is it?
No, definition, it just means it completely dissociates as strong. And then by elimination, everything else that doesn't go close to 100% is weak.
Okay, so basically it's like strong threat associated.
Correct.
Okay.
So what would be a decent threshold for actual danger?
I think he wants to pour acid on somebody.
No. I'm
Well,
interested
see,
in the
that's
pH
that's
line.
that's the thing. That's the thing. Like acids, just they spit off H pluses, and that's a destructive process.
But like acetic acid isn't that bad to hold on your hand?
Well, yeah, because vinegar is only 5%. That's the reason.
Okay.
If we were to distill it to 100%, it would do some damage, redness. And yeah.
Okay.
All right, so here we go. Acid dissociation constant, Ka. So guys, take a look at this reaction, soak it in, and tell me, does this match everything we learned last chapter?
Yes.
Okay, so if you were keeping along last chapter, and even if you weren't, but you survived it, this should still look pretty clear. Hey, welcome, sir. We are in acid base 2. So, guys, why isn't H2O represented in our Ka?
It's a liquid, and no one cares.
Equilibrium expression. Let me have Victoria.
Okay, it's a liquid. It's not.
Oh, and liquids are assumed to have an infinite concentration, right?
Yeah.
And so that's why,
We don't include it in our equilibrium.
precisely. So there's no H2O up here. Now, what would happen in the auto dissociation of water, that's just two water molecules colliding, right? Those are liquids. Was there a denominator when we did that last class, the auto
No.
dissociation? It was just OH times H3O plus, right? And that makes sense because there's no denominator. So I just want to drive the point home, guys, in case, you know, in case last class or, you know, the last chapter was rough. Remember, it's products over reactants. Very good. Okay, so strong acids, even though we assume they go what percent?
100.
100%. They're gonna have Ka values too. It's just their Ka values are gonna be very
High.
high, right? Which means which group is higher, the products or the reactants? Products, right? Okay. So let's examine some Kas. Let's examine some Kas from various acids. Guys, did we agree? Is HCl strong?
Yeah.
Does it make sense that its Ka is 10 to the 6th power? Okay. Well, HCl has proven itself. HNO3 is a little bit surprising in that its Ka is quote unquote only 30. But guys, think mathematically here. Is 30 over 1 a lot?
Mm-hmm.
Okay, that's 30 to 1, right? So, and as we'll find, HNO3 is a very interesting one because HNO3, it's not necessarily the acid part that's scary, it's the NO3 part. But we will get to that. HSO4 minus, ooh, it's got not so great of an Ka, it's 0.011. Oh, but it's not one of our big six, right? Which version of this was in our big six?
It's H2SO4.
Ah, so H2SO4 is really powerful. But here's the interesting thing. Is this a negative exponent of 10?
No.
Like
Sort
not a
of.
significant one, right? So even though it's lost an H+, does this one still have the potential to be acidic? With that Ka, yeah, it's low, but it's not low, right? So that's one of the things that makes H2SO4 particularly scary. All right, now we get into the losers. C9H8O4, 10 to the negative 4, low. CH3COOH, 10 to the negative 5th. Chaku. Now I'm going to call this one a loser, except this is acetic acid, which as we discussed earlier,
It's vinegar.
it can do stuff. So this is what I was saying earlier. This is really low, right? But it can still do stuff. So that's why all the interesting stuff for acids and bases happens with the weak ones, okay? So just keep that in mind, guys. Chaku, acetic acid, 10 to the negative 5th, it still has that acid taste, even though it's only 5% in that vinegar we use, okay? So,
The weak acids do the cool stuff, but the strong acids just melt your family and your friends. That's cool.
Yeah, basically.
That's a way over.
okay. Well, anyway,
It's also pretty warm. The reaction's very exothermic.
HCN, 4.9 times 10 to the negative 10. That's, pretty low. They will often try to trick you by throwing HCN in there. Guys, just looking at it, doesn't HCN look like it should be one? Doesn't it have kind of the look of a strong one?
No.
It has a look of it. It's just not it.
No, it isn't. It
Like it's
isn't
got an
though.
H in front,
It-
right?
Yeah, no, like it looks
It's got a
like
H. It's got a hydrogen carbon bond with a nitrogen tacked on.
So
It's
what-
very
what you guys are
stable.
saying is this carbon kind of throws it off, right? Because carbon's not very
sugar,
electronegative.
but
Yeah.
you don't-
Okay. Well, that means I've taught you well, guys. All right. So the stronger the acid, the larger the
Ka.
Ka. So we don't just look at acids, so Ka. We can also look at KB. Not to be confused with the amazing KB toys. May it rest in peace. All right. It's a toy store that used to exist when I was a child. But you guys weren't born yet. All right.
Are you saying you're older?
I am old. I'm 31. All right. So KB.
Are we still alive?
Okay, why aren't you married?
Oh.
Nah,
Good.
nah. I ain't never gonna do that.
That's too fun.
Alright.
You're-
So KB.
You know, I have that on recording now.
Oh, don't send that to certain someone.
Okay.
Alright, so KB equals NH4 plus times OH minus over NH3. Guys, from everything we've learned, does this one make sense?
Yeah.
Maybe.
That sounded so sad.
I know, I'm sad.
Equilibrium is back, guys. This is a time to rejoice.
It's sucking our
I'm
souls
sorry,
out.
like, no one has ever said that. I like equilibrium, yay.
I think you're the only person in the room with a smile on their face, Mr.
You know
Wright.
what's cool about equilibrium? It's like one of these things that at first glance looks kind of simple, but then the more you learn about it, the more you learn how complicated it is. But then the more you learn how complicated it is, you learn how simple it is.
Stupid.
It's like
Oh, here's something.
it's like Le Chatelier. You keep going back and forth as you learn more about it. You know?
Oh wait, I know this is kind of a stupid question, but the difference is that with this one, it's since H2O is the one that's the acid and that's not within the equilibrium equation, then that's why it's space dissociation.
Right, and also since you have OH concentration, it'll be a KB.
Yeah. Okay.
Yeah, so guys, generally speaking, if you have an OH in there, you can't call it a Ka. It is by default a KB.
B. What if there isn't an H plus or an OH minus in this?
It's possible.
Well, don't say that.
Oh, wait, so like.
But here's the thing though. In order for this to even work, it has to be in water. Because remember, we're dealing in concentrations in water.
Mm-hmm.
So there's going to be water there. So by default, if it's basic, there will be OHs because it'll attack the water.
Okay.
So it's like one of these things where it doesn't have to have it, but then it always will have it. Right? It's like weird. Okay, so guys, what's the KB for NaOH?
Very
Very
large
large
number.
Very
Number.
And what's the KB for everything else on this list?
Horribly small.
Yeah, so guys, the NaOH is one of our gold standards. But you know, LiOH, KOH, RBOH, you know, everything from that group. And then which ones from group 2 are considered strong?
CASRBA.
Right, now, a quick note before we move on. If you have a CASR or BA, is it going to be just one OH on those 3?
No, you
Look at what group CASR BA are. These guys are in group, which means their charge is +2, which means you're going to have 2 OHs, because each OH has a what charge? -1. So it'll be in parentheses OH2.
So what is the actual KB of NaOH? Or are you just gonna refer?
Very large number.
That's not a number. So that's
What if I look it up?
What's its exponent?
They're all variable.
Very large number.
So, wait, so then what happens if it gets on my hands?
You die.
Well, your hand is going to feel slippery, and we discussed this, guys. What do you do with your hand feels slippery when we do the lab?
You calmly run over to a sink.
Calmly go over to the sink and wash your hand. Here,
What if it?
I'm going to look up the KB of NaOH for you guys.
Can I go to the shower?
No, just
I
wash
say
your
I
hands.
wash.
everybody.
But the shower.
Okay, are you guys ready for this? The Ka or KB of sodium hydroxide is 10 to the 20th power.
Jesus Christ.
Well, I can't count that.
Me neither.
All right, well,
It's a chunky boy.
That is a very large
NaOH, anyone, huh?
Why have we never heard about like sodium hydroxide? Why have we never heard about that stuff?
What?
Why have we never heard about it? Why is nitric acid or God, what's the name of that one? NH3. Why it wasn't acid, it was the NH3 one. It had a name. ammonia or something like that. Why are those the ones that we always hear about when it comes to bases in like bleach and stuff, and not NaO3 and NaOH?
Oh, okay, very good question. It's because sodium hydroxide is too good.
It's too good.
It's too good.
It'll
Yeah.
burn a hole
You
through
don't
your
wanna
floor.
scare people.
Well, it's just like the weaker. It's like I was saying earlier. Most of the interesting stuff happens with the weaker ones. Because the strong ones just they go through and rip a hole, like they just go in like a truck. But the weaker ones, you can manage them. You can tailor them to what you need.
All right.
All right, and it depends on your application. You know, if you need a hammer, you grab NaOH. All right.
I feel like you'd need more of a power drill if you wanted NaOH, not a hammer,
All right. So guys,
or a small bomb.
we can have Ka and Kb, but we can also take the negative log of them and get the pKa and the pKb.
What does that even mean?
You thought it stopped with pH and pOH. You were sadly mistaken. We have a newly acquired toy called log, and we're gonna use it again and again.
It's like math.
I'll
all
see
over
why
again,
people
it's
see
sad.
it. I'll see what's worth
How do you get the concentration of Ka?
No, it's not concentration, because look, guys, what do they put the Ka and Kb in?
Oh God.
Parentheses.
Also, it doesn't have to be concentration, it can also be equilibrium constant.
If we're doing pK and pKb, yes.
Yeah.
But if it's pH and pOH, it has to be concentration.
Alright.
So yeah, guys, here we are. Welcome to the big leagues.
Am I being paid for this?
Next one, try to
Why aren't I getting paid for this?
I don't know. You'd have to ask downstairs,
just for this lesson.
I feel like they
Come
should-
back.
and then like come back in.
Yeah.
Can I get incentive positive cookies?
Guys, you guys will make it. I believe in you. All right, so let's look at pKa. So here, the pKa for HCN is 9.31 at 25 degrees Celsius. Find Ka at 25 Celsius. So guys, if pKa equals the negative log of Ka, how could we reverse that how could we reverse engineer it? We could do 10 to the, 10 to the negative pKa, right? This is the opposite process of this in math class, right?
Yes.
So we do 10 to the negative pKa, 10 to the negative 9.31, and we get a Ka of 4.9 times 10 to the negative 10. Guys, for an acid, is this strong or weak?
It's weak.
Okay, so it's obviously weak, right? This is not super high. Now, among the weak ones, is this a stronger or weaker one?
Weak,
It's weak among the weak, right?
but among the strong, it's also.
It's a weakling. It's a wimp.
All right,
AP Chem, guys.
now for a bit of bad news.
Wait, hold up. What bad news?
So, on the reference sheet, this formula is not available.
Okay.
The other way, this way is.
Oh, yeah, and then.
Well, finding the logarithm gives you an exponent, so you know it's going to be the
Oh,
exponent.
it's the same thing with pH and pOH, where it doesn't give the 10 to the negative to get, yeah. So guys, you need to memorize this one. And this one. And also the H3O plus equals 10 to the negative pH and OH equals 10 to the negative pOH. Because that and these are not on the reference sheet. I don't know why, it seems kind of dumb to me. But, yeah. Okay, so guys, anyone still need the slide or can I move on?
You should protest for a new reference sheet every time.
What's that?
You should protest for a new reference sheet with every formula on it.
And it describes
We should-
how to use
no.
the formula.
And
Actually,
the
we should protest for the
electro-
old reference sheet, 'cause you said
numbers on
to
the
give you a
new
5 for
reference
the, like, everything.
What about a reference sheet that just gives us all the answers?
I like
That
that.
would be
I'll be
good.
down.
What's up, Michael?
What is the P the POH or the pKa? Like what does the P do? Just put it on a scale.
Okay, so the guys, he just asked a great question. I'm gonna answer this real quick. The guy who invented it, I forget which European country he was from, but the guy who invented it and first wrote it down, he never actually told anyone what the P meant.
Yeah, it was on the slide. I'm just saying,
Well,
why
no,
are we
no,
doing any
no,
of this?
on the slide, they tried to call it power of or whatever. That's just something people threw in later to try to explain it.
So
Literally, it's just a tool to help us understand acids better.
it just puts it on like a scale.
Like it means nothing on its own.
Okay.
Like it literally, it's like formal charge,
So what I'm
It
getting
means
is that
nothing.
I can make fun of it.
but we can derive meaning from it once we use it to compare everything to each other using it.
Okay. Cool.
Yes, sir.
So, like, why did it become like a standard? Like, no one knew what it meant.
Because no one else had thought of acids and bases in quite that way. We knew, oh hey, we have this thing, it'll burn things' faces off, right? But he found a mathematical framework that actually worked with it all the time. And so he ran with it, published it, everyone kind of coalesced around it. Is there maybe a better way out there to do this? Sure, but it's like they say in business, you're either first or you're the best. This was first.
Well, POH was the
So it's
best.
not the best. You know what you're saying?
Well, the best is just never going to gain traction because the first is already
Ah.
dominant.
Well, I'm gonna make fun of the first now.
I mean, it's just kind of how it goes. You know, you're either the first or you're the best. All right. So here we go, guys. pKa. Notice just the way the numbers work, guys. For a stronger acid, what can we say about the Ka? It's going to be. But what do we say about pKa if it's a stronger
It's gonna be
acid?
lower. That's
It's
so
lower.
weird. Why?
Because when you take the negative log of something, it's like a upside down world.
Okay,
It's
so
like an
sometimes, let's say a question on the test is like, hey, this acid,
No, it'll say which of the following is the strongest acids.
and
It'll
then
give you pKa.
it'll give you like a KPA.
Yeah.
It'll give you the KPA, and then you're gonna be like, oh, LOL, the one that has
That's the lowest.
that's the lowest with the negative.
Yeah.
And but then if they give you the KA, you're like,
Well, the largest.
ugh, ah.
Yeah.
Thanks.
Exactly.
So, guys, yet another thing to try to remember. And of course, we have to make it difficult on ourselves. One of the values is higher, one of them's lower. Yay.
It's just like the stupid thermochem stuff that I never remember.
You mean the amazing thermochem?
No, it was pretty stupid.
I think I'm gonna rename it next year. I'm gonna call it the amazing. You know, like the Amazing Spider-Man. I'm gonna call it the Amazing Thermochem.
No, that is disrespect to Spider-Man. Don't do
That's
that.
also really misleading.
Yeah, but does anyone really like Andrew Garfield though?
Yeah, he was a good actor.
Was? Did he die?
Okay, he was a good actor in The Amazing Spider-Man. It's just the script
Like
sucked.
Tom Holland.
Yeah.
All right.
Hold up, I'm still writing stuff down.
Okay, no worries.
People
Okay,
arguing about.
fine. I'll call it Thermochem, Far From Home.
Ouch.
Far from an A.
Oh, Mark on an A.
We've got it.
No, I'm good.
Yeah.
Mr. White.
It's Mr. White.
I need to find out.
In previous years, yes.
Sorry?
In previous years,
Oh,
yes.
so not this year?
I don't remember.
Did they just get an A on equilibrium?
Has anybody got an A on any test ever?
I got an 86.
I got an
Hey!
89.
I got an 87 on the last test, but that's the highest I've ever seen.
Yeah.
I got like a 92 on atomic theory.
You did?
I have
Yeah.
an
Okay,
89.
fair enough.
I'm so close.
Nerd.
So close.
Is it you got a half point curve on that?
Yeah.
Mis-
Your curve should have been linear.
You know what?
Then it
That's
would
what this test is for, guys. Someone is gonna break through the ceiling.
Someone's gonna what?
Mr.
Set the
White.
curve like that.
Someone's gonna break through the ceiling.
What do you mean? Like
It's gonna curve into like a
Like an A.
Uh-huh.
Oh.
Hi, Mr. White. So naive.
I get a 0.
You're really expecting a lot. Yeah, we can do it.
You can do it.
Someone over there.
Alright, so moving on, guys. Notice, what do we say about PKB, guys?
Very large.
The KB for a base that's very strong will be
Very large.
very large. But what happens to the PKB? It's gonna get, as it gets stronger, the PKB gets lower until it gets super negative. Yes, sir.
What is the pH or Kp or whatever, or of the strongest acid that you know of?
Oh, there's one that Wikipedia has. I looked it up a couple of years ago. My class was really interested. You know, they were really involved. They loved chemistry.
Completely
And they looked it up and they showed it to me. It's like some crazy like carbon and other thing like.
Made in a lab type thing.
Yeah, it's like this super like. Oh, okay. You know, like in Star Wars, when in Episode 5, when you had your regular Star Destroyer,
Episode
and then it got eclipsed by the Super Star Destroyer came, and it like was eclipsing. You know?
Yeah.
That's like this acid.
So like, what was the number?
I'll look it up.
Probably like at least 2.
At least 2, if not lower.
Maybe even 5.
Okay,
Maybe. Maybe.
Yeah, okay, it's fluoroantimonic acid.
So if I were to drink it,
Well, the pH of it,
Why is my touch?
it has the pH listed, but that makes no sense without the concentration.
You get
zero.
Like, can I get an A if I push like acid?
Fluoroantimonic acid.
Like,
What if we just
Okay.
experiment.
Fluoroantimonic acid. Oh, this is a cool one.
Have you ever made acid?
You should watch.
We should
No,
do
no,
that.
because it's no, okay. How crazy is this, guys? So fluoroantimonic acid. Here, I'll just put it up. It's it's 2 different compounds in a mixture together. It's FH2 plus and then SbF6 minus, but they're like together. They're like not together, but they're together.
It's kind of weird, Mr. White.
It's called a super acid. So I was right about when I called it a super star destroyer. I knew that I had that joke queued up for a reason. Must have been for a couple years ago. It is a quadrillion times stronger than 100% pure sulfuric acid.
That's H2SO4.
How do you even quantify a quadrillion? What?
A quadrillion is 1,000 times a trillion.
Well,
This is crazy. It can protonate hydrocarbons, which those are very unreactive with acids.
It can throw a proton.
Hydrocarbons and to turn them into pentacoordinate carbocation.
How do you protonate something?
No,
Victoria.
you throw an H plus on it.
Yeah,
Oh, what? Michael?
I was gonna say that.
Okay, thanks.
Oh, so look, the only thing it can be stored in is Teflon.
Oh my god.
Well, I mean, like Teflon's a high resistance fluorine compound, right?
Mr. White, have you ever made a chemical illegal compound?
Have you asked?
I'm sure there are illegal recordings going on right now. So. I decline to answer that question.
Mr. White, did you do it allegedly?
I put it in the
Mr. White,
paper.
Allegedly.
allegedly. Is your real name Walter White?
You guys are too funny.
Your last name's White, and you're teaching a chem class. What do you expect?
Hey, it was an amazing joke.
They practically write themselves.
Wait, reaction.
Episode 2. Dude, literally.
It's just some really nice reactions before something does. You can purchase it on the dark web. Or you like a class, Amazon, purchase of this acid.
Oh, we should do show and tell with illegal acids.
You bring your favorite acid.
Bring my favorite, like, bro, just bring in 100% pure hydrochloric acid.
Teflon is the only thing you can consume.
Don't tell anybody.
What's the other thing that Teflon contains? Nuclear
Everything.
waste.
Everything. It holds on to everything.
No, I know, but there's another thing that's like highly bad.
Oh, they're acid?
Highly like that.
Highly
Like, it holds fluorine gas.
The pH,
Which burns
the
everything.
pH is -31.
Oh my god.
God dang.
Negative. Wow.
Wow.
30.
So I don't think you want to drink it.
Alright,
Water bed?
so
No balls.
you guys asked, and a bunch of nerd chemists delivered. Alright. So, okay. So this is just showing us, we're going to explore now the relationship between Ka and Kb. So guys, what better way to show the relationship than to explore NH3 versus NH4+, which are what of each other? What are these of each other? starts with a C. We learned the word last time.
They're
They are
congruent.
conjugates of each other. The NH3 is obviously the base, and the NH4 plus is the acid, right?
Yeah.
Well, we can use these to compare them. Now, this one is called the basic reaction because what is it unleashing?
Basic.
Oh, our original Chem Club shirt said you are so pH greater than 14.
Nice.
Or no, greater than 7. It said greater than
You're
7.
so basic.
Oh.
So it was roasting everybody who didn't get the joke as being basic,
Yeah.
or was it everyone who did get the joke as being basic?
Right.
Wait, doesn't make any sense. You're insulting yourself.
Actually, I think I'm
It's
acidic.
like, it's pertinent, right?
Alright, so anyway, guys,
Can we put permanent on a T-shirt?
but look at the
Piss off
acidic
everybody.
reaction is H3O. You might get on some kind of list. The acidic reaction is H3O plus, guys, here. So notice, guys, these are technically very similar. It's just what are we flipping in these two?
The acid and base.
The acid and base, but then that causes it to change the principal component. It'll either be OH or H3O plus. So guys, if we look at these two though, we've got our Kb and our Ka. We can take these two reactions and we can add them together. But guys, if you add reactions together, what do you have to do with their expressions, their equilibrium expressions?
Multiplied.
We multiply, because remember we multiply Ks whenever we add reactions. Oh my God, look what it does when we do that.
Oh, I cancel.
How did you get the numbers?
Hey, don't.
Remember, this is the formula we learned last class where the autoionization of water, OH times H3O plus equals Kw.
But on the last slide?
You talking about these?
Yeah.
No, they're just given.
Oh, they're given, okay, good.
But guys, if we added these two reactions together, the NH3 will cancel the NH3, the NH4 cancel the NH4. And so you just get OH minus plus H3O plus equals H2O. And so if we multiply their Ks together, which is what you do with Ks, you get that. So this is the basis for us to throw these formulas in here. Now guys, I think this one is on the reference sheet. Let me double check. Oh, it is not. Oh. That's why I remembered it. Okay, so guys, pKa and pKb, you guys were wondering earlier why the heck would we learn about it? It's because of this formula. Guys, if you know your OH or your H3O plus, you can figure out, going around, you can figure out the other thing because it adds up to what, guys? The P's add up to 14. So what that means is if you have OH minus or if you have Ka, in either case you can find the other thing, either Kb or H3O plus. You can find those by taking the what of them and turning them into a P. What do you have to do to get to here? Take the negative log and then you throw it in here and subtract it from what to get the other one? 14. And then you can take whatever your answer is as the negative power of 10, and that'll give you either the OH or the Kb.
I'm so confused. I got the K
Yeah, I'll do it on the
times
board. I'll do it on,
KB.
I'll do it on the board.
Ooh,
Oh my.
that's one way.
You guys have young eyes.
It doesn't mean they're adapted to different light conditions anyways.
Oh yeah, I forgot. You guys spent a year like in your little huddled in your little computer rooms.
Exactly.
Did you guys get blackout
Computer rooms,
curtains for your rooms?
I did actually.
I actually-
I don't even
I
have like
don't
a
know.
real
No,
Right.
it's literally the best thing that has ever happened to me. Are my blackout
How am I supposed to study in the daytime with faint light?
So what you're saying is you turn your guys' your rooms are like dark
curtains.
dungeons.
My back.
Basically, yeah.
No, they're dark, soft, cushy dungeons. It's different.
I didn't know.
Guys, what do you think about a little egg drop thing? We're doing the egg drop. We're doing the egg drop in physics.
Is that supposed to be the guy that says how an egg filling is egg?
I'm a what thing?
Had an excellent day.
With like an egg.
Yeah.
Oh.
The one from
Hey, Mr. White.
I don't know any eggs.
No.
Alright,
Is
so.
that how you spell excellent?
Yes.
Okay.
Alright,
What
so.
do you mean?
So then, guys, what I was talking about earlier is, let's find out. Let's say our KB is 1.8 times 10 to the negative fifth. If I want to find KA, wait, was that KB? Yeah. If I want to find KA, I can take the negative what of this?
Negative log?
Yeah. Guys, calculators, do this for me.
Someone does.
Negative 5.255.
Wait, did you do negative log?
Yeah, for negative log.
What did you get, sir?
4.745.
We got dissension.
4.745 is what I got.
Yeah, just cause like if you look, you got a negative here and here, so like when it goes through the magic, it should come out positive.
Yeah, I forgot to put the negative on the exponent.
Oh, and the exponent, yeah, that will do it then. Okay, so then guys, our formula is pKa plus pKb equals 14. So then I can find pKa equals 14 minus pKb.
And then you could also find KA.
And what's 14 minus 4.745?
9.255.
5. Okay, and then how do I find Ka from pKa, guys?
KA equals to 10 to the negative PK power.
Oh, I should probably write that. Guys, what is 10 to the negative 9.255 power?
How many sig figs you want?
Just give me a bunch.
5.559 times 10 to the negative 10 power. We should be valid. We did all the work.
So yeah, what do you guys think of that?
Cool. That's definitely math.
I can see it.
It just happened.
I can see it.
So basically,
on the board.
you can think of it like this. I'll give you guys a picture. So you guys like Dragon Ball? Dragon Ball Z?
Not really.
I've never watched it.
Me and some friends.
Do you guys like Power Rangers? Did you like Power Rangers?
Never watched it.
Yeah.
No,
Okay, you know what? You know
The
what?
Office.
You know, no.
No. The Office is
Okay,
bad.
we're going with Power Rangers. Okay. So KA can get in its Megazord PKA, and then KB gets in its Megazord PKB, and then the two come together in PKA plus PKB equals 14, and that's your Megazord. And then when the battle's over, when they vanquish the monster, obviously they need to go back down, right? So then if you want the other one, you just go back down, convert PKB into KB, and then you've got your KB. So like, what basically you go like in an arc around. Like if you have Ka, you go in this arc around. You do Ka to PK, and then you add them, subtract from 14, then bam. Then you 10 to the negative power, and then here. So it's like you go in a. Whoo! Instead, you can't go. Can you go straight to here? No, you gotta go like this. Yes, sir.
Can you please describe the Dragon Ball version?
Okay, so Ka goes Super Saiyan, and then it becomes PK, and then it does fusion. Ha! With PKB becomes 14, and then you just break it up back, and then you can go down to KB.
Yeah, I've never seen
Okay,
Dragon Ball. I like
now
it.
I've said all of this, and I just lied to you guys. I just lied to you.
Mr. White, how
What
good
did
you?
I say you couldn't do?
Go to.
Add
Let me guess. You can do go to
It's
go
also
from
multiply.
PK to KB.
But then they add as P.
Why do we learn any of this if we could just do that?
So,
Did you really just?
So you could just do, KW is 10 to the negative 14. You could just do KW equals KA times PKB. So you just divide it from 10 to the negative 14. But anyway, moving on. I like this way where we have to go like this.
But it's so much more work.
Mr. White, is it okay if I don't get anything right now?
No. I'm just kidding.
It's just you're saying so many words, and like okay. Imagine you're a student and you look at that board.
Yeah, pretty simple.
What do you?
I do it.
I
Like,
like what is that? Is there
Just write the stuff.
I already
in
know that I'm
yellow.
gonna confuse what you have to multiply and what you have
If
to
we're
add.
doing homework, it will make
But-
sense.
No.
Yeah, what Bianca said. Just look at what's in yellow. The other stuff is just showing you how to derive it. Just look at what's in yellow.
I've learned that when something's in colors, it's for a reason.
All right. So anyway, guys, you want me to turn the lights out or keep them on?
Lights off.
It's not.
Hey Siri, turn the lights out.
My pupils
Whoa,
have dilated
how do
too
you do
much.
that?
I gotta go back.
All right. So guys, find the pH of a 3.5 molar NaOH solution at 25 Celsius. So guys, NaOH is a
Strong base.
strong base. So we're gonna assume complete dissociation. So all we gotta do is POH equals negative 0.54, except for one problem. Guys, is POH pH?
Yes.
No.
Wait, yeah.
No. But did we just learn something special here?
Yeah.
You can add the.
together they add to 14. Wait, does that make sense? Because 14 is the pH scale.
And-
Wow.
Except for
And
when
it's
it
the
isn't.
pH scale
Except
because
for when
10
it
to the
isn't.
negative 14 is the KW of water.
That's why is that why it's KW?
And what do all these have to be in? These all, the acid-base war is fought on planet water.
Wait, is the Mr. White?
Now you lock me there.
No, water.
I feel like this is the Power Rangers.
So 73%.
Alright, so anyway guys,
Mr.
in order to
White.
find this, we do pH plus POH equals 14. 14 minus 0.54 is 14.54. Is this a scary base?
Yes.
Yeah.
And so the W in KW is water, right?
Water.
Okay, that's easy to remember.
So the
Oh, that's
solution,
the
the
So-
solution that contains a base would be acidic.
No. A solution that contains a base is a basic.
But then why is the pH that scary?
It's 14.54.
It's really high. That means it's
Acids
basic.
are below 7,
Oh, I'm
bases are above
stupid.
7.
Yes.
Oh my god.
Yeah.
Okay, I get it.
So guys, you're basic if you're above 7, and when are you acidic? When you are below 7.
So guys, since we're all above the age of 7, we're all basic.
Nah, you guys are acidic. Just ask your grades.
Okay, my grades are
That was a bit of a reach, Mr. White. Like.
You know what? It was, but you guys felt the cruelty and bullying behind it, so that's all that matters. Okay, so pKa and pKb. An acid was dissolved in water, and the pKb associated with its conjugate base was found to be 15.5 at 25 Celsius. What is the pKa value for the acid? Is the solution acidic or basic? Is the conjugate base stronger or weaker base than water? All right, guys. So how can I find the pKa if we have the pKb? Go ahead, sir. Or 14 minus that, yeah. Very good, very good. Okay, so guys, pKa is negative 1.5. Quick decision, acidic or basic?
Very acidic.
Because lower pKa's mean acidic, right?
Yes.
Alright, and is the conjugate base a stronger or weaker base than water?
Weaker?
Weaker.
Conjugate base is in fact going to be weaker than water. Water and the conjugate base compete for protons, and water is going to win every time. Because it's a strong acid. So remember, it's that argument we talked about last class where strong acids are strong because the water that the acid's attacking is a stronger base than the conjugate base. So then the conjugate base can't push it back. So therefore it is strong because it stays formed. Yes?
Can you justify just saying the conjugate base is a weaker base than water because it is the conjugate of a strong acid? Is that
Yeah.
good
Yeah.
justification? So we don't have to write down water that much?
Yeah.
Mr. White, so for B, like, do we say it's acidic because pKa
Is low.
Okay, so whether it's acidic or basic, we only go off of pKa and not pKb?
Well, I mean, you could say that this pKb is a high number, so it has to be acidic because a pKb would be basic if it was negative.
Yeah, okay.
14 minus 16, 15.
Yeah, so you do 14 minus 15 to get this one. Go ahead, sir.
Oh, that makes sense. Oh.
Alright, we're just gonna do like this easy.
What's that?
We're just gonna do this easy.
Some of them, yeah. You guys have seen it.
Oh,
Like, some questions are really easy, but then other, it's just a lot of stuff you gotta remember at once. That's what makes it tough.
I mean, like, the only math in this
On that
one.
last test?
Boo.
Literally? No,
Wait a
Mr.
minute.
White. It was one word and I would have gotten it.
You guys still need this? Alright, find the pH of a 2.5 molar solution of HF. Someone tell me why this can be tricky for kids who don't study a lot. What does HF kind of look like?
A strong acid.
It looks like a strong one. In fact, 3 of its group mates are considered
Strong.
strong acids, but F is not a strong acid.
Why?
And how
Oh wait, no,
we-
we already answered this. Never
Yeah,
mind.
because remember, it's too small that it doesn't give off the H easily. But guys, how can we know that without knowing it? What did they give us right here?
pKa.
The pKa.
Is this low enough to be strong?
No.
No.
Most of the strong ones we've seen have been what in front of the number?
Negative.
A negative.
Wait, those are the first three digits of pi. Is it just raw coincidence?
Yes,
Yeah.
No, Michael. Actually, what they don't want us to know is that pi is actually hydrogen.
Victoria?
Have you ever seen?
Victoria, shut up.
Frictionless surface, that's actually cool.
Alright, so guys, we're gonna find Ka now. And so to find the Ka, we just take the negative pK of 10, the negative pK power of 10. That gives us 10 to the negative 3.14, which is 7.2 times 10 to the negative 4. So guys, we want to find the pH of this. Oh, you guys aren't ready.
Or not?
He's gonna.
Guys, in order to find the pH, we
I'm gonna
take the
spoil
negative
myself.
log of what?
The constant.
The concentration!
An ice chart.
And
An ice
how-
Oh, no.
How do we go from a K value to a concentration number?
By walking out of the classroom.
No, not an option.
You icy it.
Ice.
Ice chart!
I hate this.
Ice charts are back. They are here.
We thought it was
They are
over.
here. Watch your language, guys. Watch your language. I know we get enthusiastic.
Ice charts are easy though.
Yeah, I know they're pretty easy, right? Especially if they're like we're just starting with 2.5 molar. Where it gets tough is like on your test where you also start with some of the product, right? But here, look. Unlike your test, what do you have here?
The zero.
Just zeros. Okay? So guys, what do we do with the reactants? Do we add or subtract the X?
Oh.
No one saw that?
It's your fault.
No one saw that.
Half of it is faded away because you keep running into it.
We're actually recording that right now.
Alright, so guys, oh wait, hold on, I'll give you guys a sec, because I know some of us are probably still copying the ice chart here. So our E line then, guys, are gonna be 2.5 minus x, and x.
I just heard you shudder.
I've not had a good day so far.
So you use Ka as the constant for when you find x, right? Okay.
I'm so sorry, say that again?
You use Ka for the constant when
Yes,
you use it to find
yes.
a.
I knew, I just forgot.
But what makes it tough is, at first here, they didn't give us Ka.
Yeah, but you can easily just find it.
But we actually just found it over here. Guys, real quick, before I go back, what do you guys notice? What is the saving grace of this problem? When we figured this out, what did we get right here? Tell me something special about it if it's a -4 or lower power.
Oh, it's,
Oh, we don't care about the bottom.
So we're not going to care about this mess right here, right?
Yeah.
So what am I going to do with this x?
Get rid of it.
Gone.
So then literally you just take the square root of this, because x times x is x squared, and that will give you the H plus the F minus concentration. Guys, I don't even know why we bother with this. Who cares about the F minus? Which one do we care about?
H.
H plus, and so what are we going to do now, guys? Take the negative log, which will tell us the pH. Thank you, Ryan.
Good job, Brian.
What I got?
Oh, thank you, Bianca. I didn't realize that he had plagiarized you.
You
I did it. I said it first.
No, you did
I
not.
did it first.
You know
oh
what?
wait, I'm supposed to like copy this now.
I mean, it might help. So, guys,
might help.
I don't, I'm not you guys, but I don't really consider this unit, this lesson that tough, because the bulk of this part we learned last class. And I want to point something else out, guys. Acids and bases are actually really friendly, in a way, when it comes to ice charts, because what are we transferring? We are transferring a single what from one thing to another?
Hydrogen.
Hydrogen plus, right?
Yeah.
Which means what are coefficients almost always for these problems? 1 and 1, which makes a nice clean plus x plus x. I just want to throw that out there.
Thank you for gracing us with this amazing question.
Yes.
For instance, assume this x equals 0 is a weak acid, is that for like all the problems we're gonna do, or just this one?
This one specifically. If it's not, you got to use quadratic.
How would we know whether to assume?
If it's 10 to the -4, or if it's 10 to the -3 or higher, you have to do quadratic.
They give us 7.2.
Isn't that better than? Oh wait.
No, this is 10 to the -4.
Oh,
which is
that
lower.
one.
They give us that, right?
What, this right here? No,
Okay.
that was our first step.
Right. Oh, sorry.
But you're right, they gave us something that quickly leads to it.
Yeah.
But you gotta be careful, some kids in a rush do what, guys? Do they remember to do this?
No.
And what do they set it all equal to?
3.4.
Which could be bad, because then they might think they had to do a quadratic here.
Gasp.
It's just because they have to do more work, not because they get it wrong.
Yeah, that's what's even worse, right? Okay, guys, any questions right now about the union of equilibrium and acid base?
Oh, I did have a pencil this whole time.
Alright guys, so right now, so far, we are almost finished with this lesson, so we're about to put the second infinity stone in our gauntlet of acid base.
Wait, you said there was 5, not 6. There were 5 lessons.
There's 6 done.
Yeah.
Oh, so one from like
Yeah, the
another
sixth stone is
chapter?
the test. Getting
Oh,
an A on the test.
Oh, come on, that's cheap.
It's not like
Yeah, but remember, 5 stones still makes you really powerful, right?
Yeah, but not the
Oh,
best.
that's
That's the whole freaking point.
Manipulating reality.
Or the stone.
Alright, what's up, sir?
Is there a quiz?
Coming up, yes.
So it's the 7th stone then.
Wait, what?
The quiz is the 6 stone. And then the test we skip, because we don't.
But it's a Canvas quiz,
We already
though.
got the 6
It's got
stone.
7 questions.
It's just as hard. Like,
Yeah, wait. It's
Well,
six,
here's
it's
the
six
Canvas
lessons,
quiz,
right?
you got your.
No,
Five
there's
lessons.
5.
What's up, Bobby?
There's 5 lessons plus a quiz, that's 6 films.
It was a bad analogy, okay? Who else disagree on that? It was a bad
I
analogy.
did.
Okay, fine.
Okay, anyway, here we go.
There's a lot of things with 7 like things you have to collect, like a lot of media.
Alright, find the pH of a 1.5 molar HCN solution. So guys, what have they given us to start with here in this problem?
PKA.
We have a
and
PKA,
moles
right?
of HCN.
And so we want to know the pH. So first off, we're gonna find the Ka. Now guys, I want to note something here. Does it actually matter if you find the Ka first? Some of you might want to find the Ka later because you don't
Oh, no.
need it right away, right?
Yeah, the ice
Because
chart you
we have
don't
to
need.
do the ice chart no
Yeah.
matter what. So many people actually prefer to do the icy chart first. All right, guys, before we move on, is this a good Ka or a scary Ka?
Oh, it's scary. 'Cause it's 10.
It's so.
No, this is a good K, right? No,
It's-
no
it's
no
very
quadratic
small.
equation.
It's this very
Wait,
small.
Oh,
how do you
that's
know
why,
how-
yeah.
oh, how do you know quadratic?
Guys, great question, guys. Someone answer her.
What's
How do
that?
we know there's no quadratic?
Less than
The-
10 to the negative 4.
Less than 10 to the negative 4.
I thought it was 10 to the negative 4.
Negative 4.
Oh.
Negative 4.
So if it said 4.9 times 10 to the negative 3.
Quadratic, babies. Let's go. Let's do this. Let's get this bread.
Oh my god.
All right, so here we go, guys. HCN, H3O plus, CN minus. Okay, guys, coefficients. What do we got? All
Trash.
right, and then what's our initial of the reactant?
1.5.
Okay, does the problem say anything about pre-existing product? No, so then what do we put here and here? Okay, and then minus x plus x plus x. Guys, boom, 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 what do we do? Do we need to worry about this x? No. Because it was less than 10 to the negative 4, right? It's 10 to the negative 10. Okay. And just let me know, guys, you guys need a second to write?
Yes,
Okay,
please.
no problemo.
Plans for the weekend, Joey?
What's that?
Plans for the weekend?
I actually do not have any, but I need it because last weekend was really stressful between Valentine's Day and Super Bowl party that I
Oh my god.
threw at my house, so.
Wow, I just
And you didn't invite any of us?
Yeah, we didn't get invited. Your favorite
And you didn't
Kevin?
propose?
No, my family met my
You weren't
girlfriend's
yet?
family. Like it was a family.
Oh yeah, we wouldn't want to be there.
Oh,
We wanted to do that too.
We wanted to be there.
No, it was great.
Did everything go well?
Yeah, no, our parents got along really well. It was good.
That's good.
Aw,
And my family likes her more than me.
Uh,
Well, my mom didn't have any girls, so you know, it's that whole lost daughter thing, you know.
Step
Which
in
is
the right
when-
direction.
You should have just had another one.
Those odds are so bad though.
How many sons?
Plus, it would be like my cousin who had boy, and then it's like, okay, here it is. This is the one, boy.
Oh.
That's the same with my parents. They wanted a guy and they got 2
Girl.
Two twin girls instead.
Well, meeting the parents is big, right, this way?
Wait, what?
That's like.
Oh, stop! All right, do we have the ice chart written down, guys?
yeah.
All right, so now we're gonna put it into our equilibrium expression. By the way, guys, real quick, what we're doing here is often an entire FRQ because have we had a lot of pointable steps here?
Yeah.
Yes.
I mean, think about it. We had to find the Ka. Is that pointable?
Yes.
We had to do an icy chart, although I will say the ice chart isn't always a point, but saying,
What
you know,
H is?
the ice chart with this could be a point, right?
Yeah.
And then this is a point usually right here, like making this claim right here, right guys?
Yeah.
Like this work with the icy chart is a point, this is a point, and then find the pH now from this would be a point. You know what a tragedy is, guys? A lot of kids, they get so stressed out, they get to this right here. What do they call this? They say this is the
pH.
pH. Cause like they're like jumping ahead of themselves. They know exactly what to do, but then they jump ahead of themselves. Oh, pH equals this. Okay, here, turn it in, right? They forget this is just the H3O plus. You have to take the what, guys?
Negative log.
Negative log. Now, I must say one thing before we move on. Ladies and gentlemen, what if they had asked for pH, but the reaction and everything had OH? What would this technically be? This would be OH, which would mean we have just one little step.
Oh, we have to
would
equal to 14.
Subtract this from 14. But it is something to remember because a lot of kids will do all this and forget that in those cases. So be very careful about that. You still get most of the points though. I want to throw that out there. All right. So how do we feel about this so far, guys?
Yeah, decent.
You know, it's one of those things you really got to practice, guys. Do your homework and submit it on time to Canvas. Or late. It's fine to turn it in a little late, you know.
Can we not get points taken off?
Now, the system's pretty rewarding, right? You know, there's a minimum of, what is it, 30%?
No, I think we not get more points
And I'm
than
like, we're getting
being on the list.
I have a question. Can we do a lab?
Labs would be fun.
We are doing a lab relatively soon.
No, but no, it isn't. It's in like 2 weeks.
We do an acid
Yeah,
lab.
it's in March. The lab's in March, man. Like, it's not.
You said last class was gonna be next week.
Well, you know,
Whatever happened to
it's a
the-
marathon, not a race, guys.
It literally is a race. Those are both races.
It's not off point. You have that knockoff point early.
Okay, so guys, let's do this one. Oh, look, this one throws in percentages. Ooh.
Oh,
What? Okay, so
Are they
guys,
relevant?
what?
Are they relevant?
Oh, yes.
Oh.
So, acetic acid, HC2H3O2. This is just a weird way of saying it. Usually we say chaku.
Cool.
So we got chaku here, guys. The experience is 0.767%. Ionization in a 0.300 molar solution at 25 Celsius. Find the Ka and the pH. So first things first, guys. We're going to do an IC chart. But are we going to use it the way we normally use it?
Oh wait,
Go ahead, sir.
don't we use the percentage to multiply the molarity by like 0.767? Yeah.
Yes.
Okay.
Yes.
What's
Um,
ionization?
And so we're going to multiply that molarity times 0.767 because, or point, I should say, 0.00767 because it's a decimal percentage. And then that'll actually give us the x, right? And then to find the E line of this original thing, it would be this minus x, which is still going to be pretty low. Okay? But guys, importantly, what does this give us? H plus.